Hello everybody, welcome to the homework helper for 1.4. I kind of did a little bit of writing, got a little bit of a false start here. But we're going to be working on the slope formula to start things off. Remember our m is our rise over run, which is our change in y and our change in x. But when we're thinking about it in terms of a formula, we need to be able to input actual numbers. And the easiest way to do this is to think of it as y2 minus y1 all over x2 minus x1. So pretty much what this means is that when we're given 2 points, point 1 and point 2, if we subtract the value of the first point from the second point, we'll be able to calculate our slope. So let's go ahead and do an example right here. When we look at this here, we have A and B. So these are our two slopes. So I'm going to apply my slope formula of y2 minus y1 all over x2 minus x1. So y2 is going to be the y value of my second point, which is 17. I'm then going to subtract y1, which is the y value of my first point, which is 7. And that's all over the x value of my second point, which is negative 5. And then I'm going to subtract the x value of my first point, which is negative 3. So I'm subtracting a negative 3, so that's the same as adding 3. Okay. Now I just need to simplify it. 17 minus 7 is 10. Negative 5 plus 3 is a negative 2. And then 10 divided by a negative 2 is a negative 5. So I know that my slope between these 2 points is negative 5. So I know that I'm going to go down 5 over 1 to connect these points. It's going to look something like that. Okay? And then you'll just be asked to do that a few more times. The next section is a little bit more in depth, so I'm going to go over it real briefly with you guys. I'm not going to be able to do all of it because you need to do all of it. In doing this process, you're learning a lot about the relationship between perimeter and area. And this is going to be an important relationship when we talk about quadratics. But Adam and his brother are responsible for feeding their horses. In the spring and summer, the horses graze in an unfenced pasture. The brothers have erected a portable fence to corral the horses in a grazing area. Each day, the horses eat all the grass inside the fence. Then the boys move it to a new area where the grass is long and green. The porta fence consists of 16, that seems like an important number, separate pieces of fencing, each 10 feet long. Okay. The brothers have always arranged the fence in a long rectangle with one length of fence on each end and 7 pieces on each side, making the grazing area 700 square feet. Okay, does that make sense? So we have 7, 7, okay, that's 14, so that means 15, 16, 1 and 1. That would be how they typically do it. Adam has learned in his math class that a rectangle can have the same perimeter but different areas. Ooh. He's beginning to wonder if he can make his daily job easier by rearranging the fence so that the horses have a bigger grazing area. He begins by making a table of values. He lists all the possible areas of a rectangle with a perimeter of 160 feet. So he's using all 16 of these 10 feet long squares, while keeping in mind that he is restricted by the length of his fencing units. He realizes that a rectangle that is oriented horizontally in the pasture will cover a different section of grass than one that is oriented vertically. So he's considering the two rectangles as different in his table. Okay, so let's go ahead and look at this table. So, length, and this is supposed to say width here. And so here we have that original one where it was 1 and 1 and then 7 and 7. Now, if we go to 2 units, then this has to be, if I had 2 units, and I wanted to use all 16, well, 2, 4, 12 divided by 2 would be 6 units. Okay. So the length would be 20 feet. The width would be 60 feet. The perimeter is still 160 feet because I used them all. But what's my area going to be? Well, it's going to be 20 times 60, which is going to be, what is that, 180? 120. Okay, 1,200 feet squared. Okay. Then we're going to do that again. 3 units, so now it's 3 units here, 3 units here, which means if we had 16, I have 10 more units to use for these, so it's going to be 5 units per side. Okay, making this 30 feet, making this 50 feet, And then it's still 160 feet, the perimeter, but now the area is going to be 30 times 50, or 1,500 feet squared. And so you're going to continue to build this chart, and then what it's going to do is going to ask you some follow-up questions, and we're going to start to be able to graph this. I have a feeling that this is going to be length. Let the length be the independent, yes. And this is going to be width, the dependent, okay? So right here, x will be length, y will be width. So use this information to complete those following questions. Then finally, rates of change indicate which is changing faster. Remember, when we're talking about changing faster, we're talking about a faster rate of change means a greater slope. So when I look at this, which one has the higher value slope? In this case, it's f of x. In this case, it's d of x, et cetera, et cetera. Now, when we're talking about curved lines, when we're talking about which one is increasing faster, we're looking at the one, again, when we looked at the greater slope, well, this doesn't have a slope, but it still has a rate of change. And which one is changing at a quicker rate? It's going to be the steeper one. And that's it. This should be pretty much review for you guys. So that should help you guys out. That perimeter problem, the big one with the fencing, is really key to helping us understand how quadratics work. So make sure you pay extra close attention to that one and do all the pieces for it. Good luck, woodchucks.